great nuisance these days. So in this study, we are going through these. These are the things we are covering in this session. Even though it is a vast area, noise pollution, it is a vast area. A lot of research are going on. With this within 1 hour or 50 minutes. So we will cover how much it is possible. I will give a brief idea about that. We will cover this what is noise pollution, measurement of noise, and the sources of noise pollution, effects of noise pollution, and what are the control measures of that. First, we will see. Before going to noise, we have to know what is sound. Okay. Sound is produced by vibrating two objects, and which will reach us to the listener's ear as a waves. So when two materials that is vibrating together, and it produces a wave, and which will reach us to the listener's ear. So that is sound, and we will see how the sound is reached to the ear and how it is processed. And another one thing is when the two objects vibrate, it causes slight changes in the air pressure. This is an example. With one example, we will discuss how we can easily study these things. So consider this is a drum, and it's having a surface. At the surface, if the surface we are striking with a stick, and the drum surface vibrate back and forth. The drum surface will vibrate back and forth. As a result, the air pressure which is in contact with the surface of the drum will move this way, and the air will compress. So that will produce a positive wave that is here. And when the waves reflects back, so that will again it's release. That is the negative pressure that is shown in this graph here. And now let's see how the noise is transferred to an ear. So this is the waves which is produced by the vibration of the object, and which will reach to the outer ear, that is called as pinna, and through the ear canal it will reach to the ear drum, and ear drum will vibrate, and when the vibration will make an bioelectrical signal, and which will reach to the inner bones like malleus, incus, and stapes, and further it will reach to the fluid field structure, that is cochlea, and when it is reached here, then further it is transferred to the auditory nerve, and it reaches to the brain, and it is recognized as a sound. That is how the sound is formed. And this is the definition of vibration, or sound. That is a vibration that propagates as a mechanical wave of a pressure and displacement through some medium is called sound. That is, the medium may be water or air. These are the mediums through which the noise is produced. And moving to the noise is the unwanted sound. Noise is an unwanted sound. So another one thing, noise is depends on the people how it is considered. Is it as a noise or a music? Here, let's see, if a man is playing a rock music, it will be a pleasant and pleasurable noise for one person, one who is listening. Maybe it is pleasurable noise, and similarly, it may be irritating noise or making an annoying noise for other person. That is called as noise. And noise pollution, that is here refers the type of energy pollution in which distracting, irritating, and or damaging sounds are freely audible. That is, which is causing an irritation to other person or distracting. That is called as noise. And already in the K2 syllabus, we already you might have been studying that first and second, third module. That is related to pollution. First module, that is air pollution. Second, water pollution, and third is soil pollution. In case of that, already in the air pollution, there are some particular pollutant, that is air pollutants, which are causing pollutions like carbon monoxide, ozone, and like. In case of water pollution, like pathogens or organic or inorganic. So these are all the physical matter or contaminants which are causing the pollution. But whereas in case of our noise pollution, there is no a physical contaminants which is causing the pollution. Here, the waves which are interfering with the naturally occurring waves is a cause or cause for the noise pollution. So noise pollution can be measured in terms of decibel units, and that is normal human ear can detect, that is that varies range from 0 decibel to 140 decibel. And if the pressure variation, already we've seen that pressure variation, if the pressure is higher, the loud sound produce higher sound pressures. If the pressure which is producing is higher, the loudness of the sound also will be more. And the pressure, usually the common unit which we are measuring in Pascal only, and the lowest sound the human ear can hear, that sound pressure which is having 2 to the power of 10 raised to minus 5 Pascal. So and also this pressure is called as threshold human hearing pressure. And this which shows how whispering, how much it causes the or what is the decibel. So if it is whispering, that will be 30 decibel, and if it is a normal conversation, it comes as 60 decibel, and that is considered moderate. And moving to this, just we were seeing a firecrackers gun blast. It is a painful situation, and which is causing 140 decibel. And that pressure which is measured, that is not possible to directly, we cannot get it to our ears. For that easiness, we are converting that into a sound pressure level, that is of considered into a logarithmic scale with relative to a reference pressure. That is reference pressure, we are taking the threshold pressure, that is already seen, that is 2 to the power of 10 raised to minus 5 Pascal. And there is an equation, sound pressure level can be find out by equation level of pressure equal to 20 log to the base of 10 P by P naught, that it gets in decibel. So the P is the sound pressure, pressure of the sound wave, and P naught is the reference sound pressure, that is the threshold, that is 2 power 10 raised to minus 5. So this is a simple example which we are getting, that is how we can convert the sound pressure to a sound pressure level. That is, if the pressure sound pressure is given 0.02 Pascal, and the LP, that sound pressure level can be found out by 20 log P by P naught, that is 0.02 by 2 to the power of 10 raised to minus 5. Then we will get directly that how much decibel, that is 60 decibel of. Now let's see how the noise can be measured. So already we've seen that the noise is measured in decibel scale, and it is considered 10 decibel increase represent 10-fold increase in noise intensity. That is like, just you can see here, 10 decibel. 10 decibel means that is a 10-fold increase, that you already see here. If it is 20 decibel, the noise intensity will be 100, that is 10 into 10 that we will get. If it is a 30 decibel, the noise intensity will be 100 into 10, that will be 1000. So that is the thing, how the decibel increase fold with the noise intensity. And the noise can be measured mainly by 2 instruments, that is called as sound level meters, and another one noise dosimeter. Now let's see how the principle or working of the sound level meter. It consists of a microphone, electronic amplifier, a frequency weighing or analyzing possibility, data storage facility, and meter display. So here this is this which shows the microphone, which is a high sensitive microphone which is used in this case. And here when the waves comes and moves, hit on the microphone, it is having a membrane, and when it hits to the membrane, it will convert the waves which came to an AC signal. So AC signal, that is converted by the preamplifier here, and after that, after converting it to a AC signal, here the weighing network or filters, here that will be converted in which frequency or how we want to measure, that we can get it done in these steps. And next is the amplifier. just multiplying for the getting the data in a good manner. For that, that will be amplified, and the signal which we got, the AC signal, that will be directly connected. That comes to, if we want to store the data, that here it is stored, and further for getting the data to display, next step is that in the rectifier, by root mean square circuits, it will converted to an DC system or DC signals. And after that, averaging system in the sense, here we want to display that signal into a decibel, so that here in this, a logarithmic circuit is that signal which is going through a logarithmic circuit, and which will display in decibel scale. And now sound level meters. Let's see, there are two types: sound level meters and dosimeters. So sound level meters, that device already we seen how it works, and it will determine the sound pressure level as well as the intensity of the sound. And it is also used in industries and environmental sound measurement. Next is the noise dosimeter. So this is an easy and simple as compared to this here sound meter. This is a small and lightweight cable-free instrument. So this is already only having it is 51 gram, that much of light in weight it is. In case of this is just hang or pinned on the shoulder, or we can say worn on the shoulder, and we can measure the sound from the industries or where the man going for work, that measures, or the sound which is coming, that can be measured directly. And here that can be a specified period, as in India, that is, or that is as per the labor rule, that 8-hour exposure is the working hours is considered. Here the 8-hour working exposure is mainly considered. And if a man is going for work, the 8 hours exposure, that the noise dosimeter is just one on the shoulder, it will be the man will continue his work, and after completion of work, the data can be collected. So here you can see here, that is the data DOS badge reader can be used to analyze or collect the data near to that. And also in another way, this is directly connecting to the PC. The data can be transferred and further processed, and we can study what is the at what frequency it is happened. And based on that standard occupational noise exposure guidelines given by the different authorities in that ISO, that is here Occupational Safety and Health Administration. So they are giving, that is as per the Occupational Safety and Health Administration, they are giving the standard value as 90 decibel for the exposure of 8 hours. If a man is working in an environment of having decibel, the noise which is having 90 decibel, and when he is it is showing the reading as 90 decibel, you should not work for 8 hours. That means the working time has to be reduced. In most of the studies, it shows that 1.33 hours reduction will give little bit of that means getting hangover from the problem. And this can be long-term personal personal noise exposure also. The long-term, not 8 hours, more than 8 hours, 24 hours also we can study the noise effect by using noise dosimeter. And now let's see with the types of noise. There are 4 types of noise: continuous noise, intermittent noise, impulse or impact noise, low frequency noise. And continuous noise, as the name indicates, it is continuous in nature without interacting, or that means without stopping. The noise, if it is producing, that is a continuous noise. That is the main example is like industries, engines. In the industries, if it is continuously running or engine is continuously running, that is termed as in continuous noise. For example, that is comes on boiler in power plant. This is also one of the example for continuous noise. And the Continuous noise can be measured by sound level meter. Next, we are moving to intermittent noise. Intermittent noise means a sound suddenly comes and it decreases rapidly. The main example is that a flight is moving, passing on us, just passing through over us, and also next a train is passing near to us. That all comes under intermittent noise. That is suddenly that increase, and after the short time it will decreasing rapidly. That is called as intermittent noise, and this also can be measured by using sound level meter. Next is impulse or impact noise. The impulse or impact noise, as the name indicates, impact means the noise is impact and sudden instantaneous sharp sound is coming. That is called as impact noise. So the main example is the demolition of buildings and all. So already we have seen in Cochin that Marad flat demolition. It was a sudden instantaneous. It is producing a sharp sound and it is explosive. So that's an example, main example for impulse or impact noise. Another one is that a pilot driving and shooting, gun shooting, and these are the examples for impulse or impact noise. Next, low frequency noise. Low frequency noise is comes when if nearby us a thermal plant or a power generating plants are nearby, or roaring large diesel engines are working. So roaring sounds will comes to us continuously to comes. That is low frequency noise, and that can be measured with sound level meter with octave band analysis. Octave band analysis, that nothing but that noise is recorded with sound level meter, and after that it is separated or break into different parts, and the frequencies are analyzed, and at what frequency it is produced. That we can find out that is the type that comes under low frequency noise. Next is just we can move to the noise of sources of noise pollution. That include household sources, social events, commercial and industrial activities, and transportation. So household activities like that in the house itself, the sounds comes from food mixer, grinder, vacuum cleaner, washing machines and dryer, or cooler, TV, loudspeaker, or even a dog barking from neighbor house. That all comes under household sources. And these are the values or decibels of sound which is produced by different home appliances. That is washing machine, it is producing 70 decibels, and mixer grinder 90, and it shows the values for different home appliances producing the sounds. And next is the social events. Social events means that comes. Hello?
Sir, sorry for the interruption.
Okay.
15 minutes.
Okay.
Session time. Question നമുക്ക്
Pardon?
last നമുക്ക് discuss ചെയ്യാം. Session continuation.
Okay, fine. Okay, social events that comes with places of worships where gather and discuss parties or market where people sell goods with loudspeaker. Places of worship that may be mosque or church or temples where the peoples gather and the loud noise which is produced, that also comes under social events. Next is discourse or parties, and next the markets where people's goods sell goods from the market. This all comes under social events. And here here a table which shows a study was done by a study on noise pollution on metropolitan city Mumbai. That is on Ganapati festival. It is the sound level which shows 116 decibel, and it is shows a higher level of noise. And next is Navaratri Mahotsav, which is shows 114 decibel. So it all comes from a large or higher cause of noise pollution comes. And according to a study conducted by a residential area in Delhi during Diwali festival, the average noise level which they found as 76 to 80 decibel. But in usual, before the festival, that value was 57 to 67. It is almost 1.2 to 1.3 times higher than the normal days the noise which is coming. So these are comes under social events. Next is commercial and industrial activities. In commercial and industrial activities like printing press, manufacturing industry, construction sites. And the construction site, that Atmaka et al. Made a study, and they found that they made a study in concrete transverse iron, cement, and textile factories located in Turkey. And it is found that all industries, which all the industries, they made a study that all it is found that pollution, that is, or noise pollution, and that is as decibel, which is showing 80 decibel. It is more for industrial area. And these are the sources of construction noise: pneumatic hammers, air compressors, bulldozers, or loaders, dump truckers, pavement breakers. These are the sources of construction noise which is causing. And these are the sources of industry noise which is producing fan, motors, compressors mounted outside. And it is found that in one study that is found that the people, those who are working in the industries, are facing a problem of hearing loss and in common. And next is the transportation. The fourth type is transportation. It comes to road traffic noise, air traffic noise, or road traffic noise comes under car, truck, and which are moving through the roads, that comes under. And the next is the aircraft noise, which is produced while the moving of the the aeroplane, which is causing, that is called aircraft noise. And next is the railroads. That is, from the studies, it shows that 120 decibel at 100 feet far, it is producing 120 decibel of sound. And if it is if some workers, if that same case, if the workers one who is working in the track at that time, that pressure, that is that sound, which is the intensity of sound, that would be 138 and 140, it is found. And this is the standard for standard given by the Central Pollution Board of India. So that is industrial area, that is daytime it is 75, and night it is 70. So day, in the sense that is they consider that is from morning 6 to 9 p.m. and next night it is considered from 9 p.m. to next day 6 a.m. And here for the commercial area it is given 65, and residential area it is given 55, and for the silent zone it is given 50, and in the night it is given 40. The silent zone, which comes which is a place where the hospital or the education institution and courts, and there where already the vehicular horns and loudspeakers are already banned. And saying four categories, they made a study, and in the Central Pollution Board given 4 categories, and they made in Delhi they made a study, and it is found that the silent zones, so most of the, it is producing 73.53 decibel. So here in silent zone, it is given that it should be the limiting value of 50, but which is producing that is of 73 decibel. So that is a more higher noise it is coming. Now just let's move to the effects of noise pollution. And effects of noise pollution, that we can be classified into three ways. That means it will affect in 3 ways. That on the it will affect on the environment, and on the animals, on the human health. And first we will see how it affects on human. So effects of noise in pollution in human. First it comes of deafness. So continuous exposure to a noise place, which the human get irritated, and further after a few days he will become deaf. And in studies it shows that first, for continuous exposure to the noise, first problem which arising is that inner and outer hair cells of the cochlea get damaged. So that is the first thing which is happening, it will get damaged. And another one things is that the people's adults, the children's will be get affected as faster as compared to the adults. The children are more susceptible to hearing loss as compared to the adults. And next is children, if they are exceeding 120 decibels, if they are exposing to 120 decibel, above 120 decibel, so the hearing loss is already, it is found he will become deaf. That is the maximum value. It is most of the research it is found. And next is that auditory sensitivity. And auditory sensitivity, that is an important thing, which already we've seen that auditory nerves, the sound will reach to the auditory nerves, and then it will reach to the brain, and that brain will accept it as a sound. So if the auditory sensitivity is getting damaged, so the sounds which is coming to our ear, that will be like distorted. That is called a paracusis, a disease called paracusis, that distorted like sounds we will receive. We may not be clear what it is, what the sound it is coming. And then next it is coming the tinnitus. So that is the like sensory effects. That means, so when we exposure to high noise, so after even for some times our ear will get rings, like, or it will make some sounds like ringing in the ear. So if it is that may be sometimes after 24 hours it may be reduced, and even continuous exposure to that same intensity of noise, that may will make to the continuous or the permanent damage of the ear. And in the most of the teenagers attending pop concert and discos, it is found that they are getting more damage. That is a study made by the Hettu and 14. It is found there. And next is a communication interference. So communication interference is basically masking process. That means, just considering, if we see that in a restaurant or a market, so the different sounds will come combining together, and we may not be able to convey what we want, or we may not able to communicate with the other people's one who is sitting beside us. So that is the masking of the masking of others noise. It is called as speech interference, and which may cause many problems, like a problem with concentration or fatigue. We will be more fatigue and irritation. So while we are conveying something to other person, if not reaching to, again we have to put more effort to reach the things to other person. So in that situation we will get irritated and misunderstanding. So if we are conveying and it may not be conveyed to him in proper way, that may misunderstanding will happen. Next is the decreased working capacity, and that is so the capacity of working environment will be reduces, and problem in relations, human relations is also found, and stress reactions. And another main thing is stress reaction is that while we are conveying, and after further we are just informing or just telling to someone, but he is not getting conveyed, or that time we will get stressed. Next is sleep interference. So this is one of the most important thing, as science says that sleeping is the most important thing in our for a better health. So if the health is not proper, automatically the body will get disturbed, and a lot of the problems will comes face. We have to face a lot of problems, and if the studies shows that difficulty in falling asleep, if the noise exposure in nearby rail track is going on, the people, those who are side of the, if the house is near to the railway track, so the people's falling to sleep, that will get late. That means they cannot go to sleep on time. And next is awakening, or in between, if the higher noise, if a train passing, so surely he will just awake and his sleep may get disturbed. And the next is the alteration of sleep stages or depth. So if you are getting a good environment to sleep, so we can sleep comfortably without any disturbance. And if the depth of sleep, that means we can the sleep will be of comfort. If there is any disturbance, surely the sleep will the depth of sleep will get reduces. So next is the psychological disorders. So first is neurosis, is like a mental disorder by increase of stress. Next is like continuous if the sleep is not well, so there is a chance of, and continuous exposure to the noise, and these all things will comes to cause neurosis, and it is a mental disorder. And another one is anxiety. Anxiety also will increase if you are exposed to noise for long time. And hypertension. So while we are exposing to higher noise, surely the blood pressure will get increases. And next is nausea and fatigue. That is like we are getting a tendency to omit. And next is the visual disturbance. So there are chances of fainting. The higher noise impact will cause a fainting and visual disturbance. We may not be able to see what is there. And already last we've seen that reduced depth of quality of sleep level, and resulting in constriction of blood vessels. So the breakage of blood vessel also may happen. And here we're showing the noise intensity and what all the problems may arise. If it is a 80 decibel, there are a chance of annoyance, and 90 means if it is a hearing damage, and 130 means so nausea, vomiting tendency we will get, and if it is 160 rupture or temporary, or chances of like breaking like we will get, and if it is more than 180, there is a chance of permanent damage of the ear. And this is lack of concentration. So just think that if our office is situated to near the roadside or the city, so the people's concentration will be less as compared to a comfort zone where there is no disturbance by the vehicles. So this the concentration will get reduced. Next is the fatigue. Fatigue means we are getting tired. If the noise pollution is concentrated on, we may not be able to concentrate on our works. And also next is that abortion is caused. So if the studies which shows that we are continuously exposed to the noise, there are chances of the getting abortion also. If that is in the time of pregnancy, that should be a pleasant time is needed. If it is not there, there are chances of getting abortion. And next is let's moving to noise effects on environment. So noise also has that growing plants. So as like a human, so they need a pleasant or calm environment, so the productivity of the crops will increase. So it is found that is the growth of some plants is deteriorated because of the higher noise exposure. And next is the birds. Birds hearing to help to so while getting searching for food, some birds are finding the other bird by their sounds. But if the noise are higher, so they are not able to find the prey for that. And the calls also process that already said the crops yield will be get reduced. Next, noise effects on animals. So first is the noise. If continuous exposure to the animals, if the higher exposure of noise, which may damage the nervous system and also increase the death of the animals, and become danger for attacking. So if you're if the sounds higher in near to a cow or like a dog, so it starts to attack. So that the things will happen. And in case of a dolphin and mammals like a whale, they are by the sound only they are finding the food. So here we can see here for the communication and for the growth and reproduction. So this all are by the sound only. They are by sound only they are conveying the things or communicating. So if you are using like a seismic acoustic survey ships, so the waves which is coming or sound waves, higher sound noise, which will disturb their life also. And other studies which made in rats and that poultry farm and all, it is found that ovaries and uterus diminished in rat after noise exposure of 110 decibel for 5 minutes, 15 days for 15 days the exposure for 110 decibel, which is causes the ovaries and uterus diminished in rat. And next is the increased abortion frequency and fetus resorption in case of rat. The study already conducted. And exposure of rats to noise of 50 to 80 hertz, kilohertz to 80 to 90 decibel in 4 days, which is showing that is the reducing the fertility of the rat. And next is the sound emission of frequency, which is showing higher exposure. It is showing that the hungry or the appetite reduction of animals. They may not be able to eat the food. They are not feel comfort to have the food. And it is found that higher exposure of noise in the to the cows, which is reduce the milk production. And next, in case of the pig, so higher exposure of noise, which is decrease the growth of the pig. And egg poultry, that the production of egg also reduced if it is exposed to 120 to 130 decibel. So now let's move to the noise control measures. So noise can be controlled by 5 methods, that is elimination, substitution, engineering control, administrative controls, and personal protective equipment. So elimination in the sense of just eliminating before planning any work or any industry. From that source itself, we are planning in such a manner that we are eliminating the noise. That is a process which is reducing. That means a process which is having lesser noise. We are adopting that option in that. And the next is work process, selecting new equipments which is having less noise. And the next is the proper maintenance of the machinery. And this is a purchasing new planned equipment that produce less noise. That is the eliminations from the source itself. We are eliminating the noise. There should not be any noise further when it is working, or in case of industry. Next is substitution. Substitution means already there is an existing industry or anything, so we are just adopting or substituting already existing. We are using some material or something. We are substituting, instead of using material, another one which is producing lesser noise. That is, for example, here replacing a rivets with a welds. So here this is a rivet joints. Rivet joints mostly we will see in railway bridges and railway over bridges. So instead of these rivets, we could use that weld, which will reduce the sound. If the rivets are provided, so there are chances of higher shaking and higher levels of noise. If we are using substitution method, instead of that rivets, we can use weld. And that is another way, like is metal to metal contact. We could use like plastic bumpers, so that the metal to metal contact that can be avoided, and the sound will get reduces. And adding noise barriers, noise closure, vibration isolation, mounting, lagging. So some other methods which we reduce the noise, that we can use it. And this is the way that substitution. Next is the engineering control. So in case of engineering control, we are making, that is using screen or barrier enclosures or absorbent materials that we are using as an engineering controlling measure, controlling to prevent the noise from that. And next, separating the noise, just already existing an area, there is noise producing. The people near to that, they should not face problem. For that, we are making some absorbent or some barriers or to prevent that noise. That are the things we can adopt. Next, using conveyor belts rather than rollers. This is also another one engineering way we have to design in such a way which will make effectively. These are the engineering control measures. And this which shows the control. We can control the acoustic fiberglass, acoustic form, acoustic partition, just making a partition so that we can eliminate or reduce the noise. And next is the administrative control. If the 3 cases, substitution, elimination, and the engineering control, if it is fails, so then we can go for the administrative controls. So administrative control, that means we are organizing. Already there is already exposure of higher noise in industries. So what we are planning is here, the workers which they are going, we are making a correct schedule for them. that means if 5 people are required for a work, we should take it 5 only. The other extra we should not take. And notifying people in advance that is a noisy, and they have to take the precautions before that. And if that is sign postings, we have to provide like no, this is a noisy area that we are giving in advance, that before entering to the job part. And next is that personal protective equipment. So personal protective equipment means that while they are entering to the noise exposed area, so we are using like ear muffs or ear plugs, or that alternative ways we are giving a personal protective equipments for them, so that that will be protect them from exposure of noise. And like the staffs, those who are working, they have to guide them, guiding and making them compel to wear the protective equipments. And these all the ways, or instruct to wear the personal protective equipments to reduce the noise. So these all things are comes in module number 4. Okay, thank you for your attention.
Hello, sir.
Hello.
There are a few questions which came up.
Fine.
First question, how can we control or reduce noise like continuous noise?
So that you can use here like engineering control measures here, like barriers, screens, or that we can provide. So that is another first way. If it is not possible, then we can go for that personal protective. In case of refinery, and continuous noise comes in like in refinery or continuous light. So in that situations, we are going for the personal protective equipments. So that is compulsory. The PP, the personal protective equipments, has to be compulsory for them if they are wearing, so that we can control. Is that clear?
Yeah. Next question, how can we take precautions having frequency other than audible range?
Pardon?
How can we take precautions against sound frequency other than those at audible range?
I'm not getting actually. Hello?
So the question is that how can we take precautions against noise which is having frequency other than audible frequency?
Yeah, that is already we seen that, right? Control measures means that is higher frequency. If it is having higher sound pressure, means surely it will have the higher frequency also. So that is these measures which we given this all the control measures. Therefore, we can give to reduce the that measure. We can reduce by these methods only.
The next question is, can electric vehicles eliminate or reduce noise pollution produced by automotives?
Hello? It's not clear.
Can electric vehicles eliminate or reduce noise pollution produced by automotives?
Yeah, obviously. So that can be reduced now, as compared to the other vehicles, the electric vehicles, which is having lesser noise only.
Okay. One more question, can constant noise make humans sick?
Pardon?
Can constant noise make humans sick?
Common noise. No, if it
Constant
is
noise.
that is already, if we are continuously exposing to higher noise, that is, if it is like already we seen now in the first slides how it is. So here you see here, if it is below 80 decibel, so that is common noise. That means while we are communicating, that it comes only 60 decibel only. So that will not cause any problem for us. So if it is coming to 80 only, that is cause annoyance, and if it is 90, that is causing hearing damage and all. It is that will not be cause any problem for us.
So one final question, do we have methods other than sonar that can be used in ships by which we can protect sea life?
Other than sonar?
By which we can protect sea life? I think with this
So there
noise,
is no, it's actually, there is no other options nowadays. There is no other options are available for controlling. That means in that area, like sonar noise cannot be controlled.
okay, sir. I don't think any more questions are there. Right? All questions have been finished.
All right.
Thank you, sir, for taking the session. I hope all students gained valuable insights into this topic. Thank you.